What is electric power steering? It is key to modern steering. With an electric motor, sensors, and a control unit, EPS helps the driver turn the wheel with less effort. By adding motor-assisted torque, it keeps steering smooth at any speed. Today, it is used in many modern vehicles. But how is an EPS system actually made? Let us take a closer look. The process begins with aluminum ingots over 95% pure. Workers separate them into prepared batches. Whenever one furnace is emptied, it is quickly refilled. The lift raises the load upward. From there, the aluminum ingots are moved from the first floor to the second. Inside the furnace, temperatures pass 800 degrees Celsius. In only a short time, solid metal becomes molten aluminum. At this kind of heat, no worker can safely stand close. So here, CNC-programmed robotic arms take over. Safely. First, the robot fills a ladle with molten aluminum. Then it pours the metal into a die casting machine. Once the aluminum cools and hardens inside the mold, the main EPS housing is formed. The power housing, depending on the vehicle brand, the cylinder shape may vary. One thing remains. The material has to be strong and reliable. Aluminum offers strength, low weight, and resists heat and corrosion. If you live in a cold northern state, road salt damages cars. It can cause more damage than the snow itself. That is why aluminum is so valuable in automotive parts. While the casting area stays busy, the next workshop is also moving fast. Workers keep the line running. Next comes machining. The parts continue forward, but now they need precision machining. Some details are almost impossible to see, like the bearing seat surface and the screw holes. For this kind of part, tolerance must stay within 3 microns. If the part stays inside that limit, it can pass as a qualified component. At the end of this line, 3 automated drilling units handle the next operation. This is also where the EPS motor, stator winding station, is located. The work is mostly automated. The only manual step here is placing the insulation module into position. Later, copper wire will be wound around this area. First, the robotic arm takes it and places 6 pieces onto the tray. Once the tray confirms the load, the track moves it automatically to the second winding station. Now, steering motors are wound with enameled copper wire. This EPS motor is no different. Enameled wire is a copper conductor covered with a thin insulating coating. That coating helps protect the copper winding. It also improves corrosion resistance. That is why copper remains the standard. For electric motor windings, even more expensive metals would not be a practical replacement. At this point, the 7-bundle stator winding begins to take shape. The coil takes shape. The copper windings look thick and uniform. Each section rises to nearly the same height. Once the housing and motor winding are ready, they can be assembled into one unit. Because the fit is precise, machines are used to help with assembly. First, the winding is placed on the center tray. With steady pressure, it slides into the housing. Of course, a complete electric power steering system is not just a motor. It also includes springs, sensors, and an inner shaft. This shaft is made from high-grade steel. Before final assembly, the worker slides the shaft inside. Then a sensor is added, with yellow lubricant applied around it, along the side. From above, the electronic circuit board can be clearly seen. So how does the factory confirm that this EPS unit meets automotive production standards? The answer is final testing. First, the steering wheel is connected to the sensor. Then the operator turns the wheel by hand. The monitor shows whether the unit passes or fails. 20 years ago, a line like this would have been considered highly advanced. It represented a strong standard for automotive production. By today's standards, it is not the newest system, but it still meets safety standards.